From the very beginning, Windows Phone 7 was intended to be a great gaming platform. And so along with that, we as developers need to have a great set of tools for building games. And that's what XNA is. XNA is a game development platform. It was released by Microsoft and originally intended for building games on the Xbox platform as well as games that could run in Windows operating systems. But when the Windows Phone was being released in Windows Phone 7, they included support in the XNA development tools for building applications that would run on Windows Phone. And it provides an extremely easy framework that you can use to build game applications. All you need to do is create an XNA project, add your assets, the images and sounds, etc., that your game is going to be displaying to the user, and then write your game logic. And I say that's all you need to do. Well, of course, somewhere you got to get your images, and somewhere those sounds have to be generated, and your game logic might be very complex. But what XNA does is it abstracts away all the things that you would have to think about, like writing to the screen and dealing with hardware and all that. It just abstracts those away. It gives you a nice, clean class that you can just write your logic in, and it'll go take care of doing all the hard work for you. If you have done development on Windows Phone or even on other platforms using frameworks like Silverlight or WPF or just even Windows Forms or whatever, it's important that you realize that XNA is about building games. XNA is not about building rich application user interfaces with grids and list boxes and drop downs and all that kind of stuff. It's also not going to be the application that we implement business logic in. Right? So what does that mean? Well, it means that, first of all, there's no controls per se. We're not going to drop a button onto a form in an XNA application. With XNA, if you want something to draw on the screen, you have to draw it yourself. The game basically is a continuous loop, and you'll run that same logic every single time through that loop. And things like events, and by events I mean those delegate type events, the click event for a button or that kind of stuff, those don't really exist. I mean, we will have some events in XNA, but certainly not like we would in a regular business application using Windows Forms or Silverlight or WPF type development there. The other thing that might be a little bit different for you, depending on your background, is this idea of retained mode versus immediate mode. And retained mode is what we're typically used to with our Forms type application development environments. And that's where we just describe to the runtime what we want on the screen. We say, hey, I'd like to have a button over here in that corner, and could you give me a list box over here next to it, etc. And then we leave it up to the runtime to figure out how to draw it and when it needs to put the pixels up on the display and all that kind of stuff. As things move across that screen then, or if I need to actually relocate a control itself or something, I do that through properties, etc. And the runtime determines which regions are no longer appropriate and that it needs to repaint them, based on the changes that have occurred. So we don't have to repaint everything every time ourselves. We leave it up to the runtime to take care of that for us. Immediate mode, on the other hand, is when if you want something on the screen, you draw it. And you have to draw the whole screen every single time. So there's no persisted region of the display that you can just sort of set and forget. You've got to redraw the screen every single time, which means you've got to always be aware of where everything needs to be, and you have to actively draw it on the display. So Silverlight uses that that form-based type application development scenario where we use retained mode, and XNA is more immediate mode, where we're drawing everything on the screen every time we want to see it. So I've mentioned once or twice that XNA games are basically just a continuous loop. And inside that loop, or at least around that loop, there's 5 major methods that you'll deal with. When your application first starts up, we'll have an initialize method that we can write our own code in. It'll be called for us by the runtime, and that's going to be where we set up the game. Any pre-game work that we have to do, initialization of variables or things like that, we can do inside that initialize method. Once that's complete, the runtime will then call load content, and that's going to be where we go out and pull in the graphical images or gain access to the sounds, etc. We want to get those as ready as we can so that when we need them, they're already in memory and we're not slowing the game down to pull something off disk. We then get the update method called. And the update method is really the beginning of the loop, and that's where the bulk of your game logic is going to be. That update method is going to be called every single time this game loop repeats, and that's where you'll decide, hey, has the user clicked on something? Does this image have to move? Should I be playing some sound? What's the user's score? Did somebody push a button? All that kind of stuff. That's the work that you'll be doing inside that update method. Once the update method has figured out what's going on in the game and what should be being shown to the user, we then call the draw method. And the draw method should be as simple as we can keep it. And that's where we actually use the logic or the results of the logic that we executed up in update, and we actually draw the things onto the screen. That's where we draw the entire display every single time. And then when draw is complete, it goes back to update. When update's done, it goes down to draw, and we just loop through those two repeatedly until at some point you decide the game's over. The user won, the user lost, the user quit, something like that. And at that point, we'll exit the loop and pass control downstream to another method called unload content, where we can release any memory assets, etc. there, and then the game can exit out. So 5 simple methods, update and draw are where the bulk of your work is going to be done, and you want to keep as much logic out of draw as you can just so that it runs as quickly as possible. Also, you may find that XNA, the runtime, is monitoring your application's performance for you. And if it sees that your application is running slowly, it's got to somehow try and mitigate that. And the slowest piece of the system is drawing, getting all that stuff up on the screen. And so what it might do is actually skip a call to draw so that it can get back and update again. The update's typically very time-centric. I need to know, hey, did you get to that goal fast enough? And so if we let update skip, we might lose this concept of time. So just be aware that draw may not always be called for you if we're in a performance-heavy scenario there. Update draw, that's that loop that we're going to go through, right? So once our game is started, we enter into that loop. And as we said, then update's going to be where you do all of your game logic, figuring out certainly positions for graphics. So you're going to have a way of maintaining that information. Where should every image that I want to draw be at? We are going to be checking for user input. Now on the phone, of course, we've got the back button that they might have pressed, but we also have touch, we've got accelerometer, we've got a few other things that the user might be using for input. We also might need to be doing object management. Did 2 different things on the screen collide with each other? And if so, how do we respond to that? Do we make them bounce off each other? Or do we show an explosion, etc. there? Keeping track of scores, it's all that. Pretty much any logic that your game is going to require is going to be at least called from update, if not in update itself. Draw then uses the result of the logic that we ran up in update and then actually draws the stuff up on the screen for us. And as I said, you want to keep as much logic out of draw as possible so that it runs as quickly as it can, because if things do slow down, remember, the runtime can skip draw. So to create an XNA application, we're going to go into Visual Studio and create a XNA phone application. And that'll give us a new solution inside Visual Studio, and we'll get 2 different projects in there. One is going to be the game, and in fact, there's a game1.cs class file there by default that implements those 5 methods, the initialize, load content, update, draw, and unload content. So all of your code is going to go into that game1.cs file. The other project is your content project. And it's into there that you're going to load all your media assets, right? The images, the sounds, etc. that you're going to be showing or playing during the game. That's where those will be stored. And then when we go in and do the builds for this project, the project infrastructure is going to go format all that media for you in some XNA compatible format there. So it'll make sure that your images, your sounds, etc. are all in a format that can be played by the XNA game on the phone. And that does mean that you may encounter some source media that doesn't quite work, and you'll have to go through some pre-conversion process before you can load it in. But basically, if you add something into that content project and it doesn't burp and it gives you nice names and tells you that it recognizes it, then you're good to go, and it'll get built properly for you. Now, if you were to just make a brand new XNA game project and not do anything to it, when you try to run it, you'll end up with what's typically referred to as the XNA blue screen of life. And the reason that happens is that the default game logic that's implemented by the project template just draws a blue screen for you on the game's display. In the case of the phone, that would be on your phone screen. So it's inside that draw method that happens there. So when the draw method runs, at least initially, there wouldn't be anything on the display. But inside there's actually a statement that tells the graphics device to clear itself. Now, if you think about what that means, this is the draw method. And remember, the draw method gets called every time we go through the loop, which means every time we go through the loop, we're clearing the screen. That gets back to that immediate mode we were talking about, and how you're going to be responsible then for redrawing the screen after you've cleared it. But notice that line of code says graphicsdevice.clear, and then in the arguments for that is a color.cornflower_blue. And that actually sets the background color that will be set on the screen when it's cleared. So once that base.draw gets called, we actually end up with this blue screen out there. So when you build a brand new XNA project and you run it, it's good to see the blue screen. We know then that means everything's working. So let's go create an XNA project. I've got Visual Studio open and no project loaded. So to create my XNA game application, I'm going to go to the File menu, come down to New, and Project. And under the list of installed templates, I'm going to come down to XNA Game Studio 4.0. And you will have that installed as long as you installed the Windows Phone Developer Tools off of the App Hub. But if I select that category of installed templates, and then over here look at the different project types, notice the top one up there is a Windows Phone game using the Game Studio 4.0. So that's going to be what I'm going to create. And I'll come down here and pick a path for this. And I'm going to call this my WP7 XNA sample. All right. Because I'm going to be doing this against OS 7.1, I want to make sure to pick that as the target operating system and say OK. And you can see then the two different projects that get created for me. I've got my game application up here and then a content project down below. And inside my game project, there's this game1.cs code file, and that's the file that's open for me by default over here inside the code window. And if I look through this file, I can see that those methods that basically make up the execution of my game are right there. So there's my initialize. Then we go through load content. Once that's done, we'll enter this loop where update and draw get called repeatedly. And then once we exit the game, we'll go back and call the unload content, the method in there. So initialize would be where I'd go in and do any initialization logic. Make sure that when you're in these methods here that you leave the call down to base. And in fact, the comments are instructive of where they recommend that you do your logic. Here they're saying call your logic before you call base.initialize. Similarly with load content, they start you out with some stuff and then give you a to-do comment where they would ask you to do your own loading. The update actually has some initial logic inside there. And in fact, you can see that there's one line of code that's actually checking for my gamepad from the player one's controller to see if the button called back was pressed. And if it was, we exit out of the application. So remember that XNA can be used for Windows Phone, but also for Xbox and Windows applications, where in those platforms you might very well have an actual controller hooked up to the device. In Windows Phone 7, your back button in the application is the hardware back button on the phone, right? So that left pointing arrow down at the bottom of the phone device. So it would check for that same back button on the phone and exit the game for you, where you'd press that. This is going to be really where the meat of your game goes, is underneath that to do. And then, again, make sure that you leave the call down here to base.update. That's what says call the update method in the base. The other thing you'll notice is that we're passing along this game time. So XNA is always keeping track of time in the game, and we can use this game time certainly as a token that we pass through to the other methods, but we can also use that for our own purposes if we're doing time-centric logic. And then we get down to the draw method, and there's that line of code where the graphics device clears its screen with some default color on the background. And initially, the project templates from Visual Studio, we'll set that to cornflower blue. And then we call the base draw. All right, so here it is. All that logic's there. I'm going to go ahead and just run the project, and it's going to spin up my Windows Phone emulator for me. Because this was a phone game, it knows that it needs the phone emulator. But you'd follow a very similar pattern if you were going to be creating an XNA game for Windows or for the Xbox as well. And there it is. There's my blue screen of life. So that blue color that we're seeing here is because of that color.cornflower blue that we had back there in the draw method. And so just to show that, if I were to go back here and stop my debug, we could, of course, change this to something else. So I'll do color dot, and we'll pick something that's hard on the eyes here, red, and run it again. Pull my emulator up. Sorry, there we go. And notice that now I've got this red screen. Now, actually, what's happening is that, remember, this update draw loop is running right now. Now, on the phone, in fact, that's going to run for you about 30 times a second. On the Xbox or Windows, it could actually go faster, and it defaults to 60 times a second on those devices. But for the phone, they've set the default on that to basically 30 times a second. And that's should be typically perfect. Anything faster than that would likely be overkill on that phone device and could end up just causing performance problems rather than making things look faster. So I would recommend against trying to tweak the timer that's being used behind the scenes. Although you can, I'll let you look into the documentation on how to do that. But 30 times a second should be plenty fine there. And in fact, if anything, the runtime may end up having to slow things down for you if we get to where the game is causing some performance problems. So anyhow, so there's that red background. And every time we go through that loop, it's actually completely clearing the screen and then repainting it red. And it's just happening fast enough, 30 times a second, that we don't actually see any flicker going on there. So we can stop this, and in fact, I know that when we come back in here, I'm going to want this background to be black. So I'll just set that to black now. So that's our first XNA game. Admittedly, it's a pretty boring game right now, so we'd want to do some work to make it a little more interesting. But we see the overall infrastructure.